Greetings from Texas. This video is in response to an assignment made by Paul McWhorter in his Sunfounder AI Fusion class. And this is Lesson 11, the assignment that was made in Lesson 11. And this is what I documented as being the assignment. Blink the red LED using a weight value that is input by the user. Now, the red LED must be blinking while the program is waiting for the user to input a blink weight value. So that's the part that makes it hard. In my way of thinking, we would create a background process or put the process in the background and then pass it the parameters. So in this case, we're going to implement a thread, aka a background process, which continues to turn the red LED on and off. And when we receive input from the user, then we will put that value into the weight. And in my case, I want it to be between 1 second and 0.01 seconds. And this is the weight that it's on and the weight that it's off, so it's not the total cycle time. The extra effort that I put into it, I'm going to validate the number that's entered by the user in a regular expression. So I'm going to bring in the regular expression and build one in Python. And then, of course, the thread has to be terminated gracefully. You don't just kill everything. So this is my setup. I've been running this thing on just the battery on one charge that I gave it a long time ago. And for the first time, I had the battery go below the level that the Raspberry Pi would stay running. And it threw me for a loop. I couldn't figure out why the Pi wasn't staying on when it looked like the Sunfounder seemed to be powered. I had lights on it. So it took me a little while to figure that out. Those of you that run into this, if the Raspberry Pi doesn't stay on by itself, charge the battery. Okay, so now you know what I learned. This is the program that we're going to look at. We're going to create a pin that we can turn on and off from the Fusion hat. I'm going to import time. I'm going to import the clock second. The perf counter is as clock second. We have to import threading and then the regular expressions. All of this is pretty standard. The LED red pin is 17. We turn it on as an output. We're going to set it high. We're going to start off with it set high. It's kind of related to the way the black background process works. I wanted it to be on, and then I'm going to use toggle instead of set high and set low. I'm going to start off with a toggle wait time of a ½ second. This is the definition of my thread subroutine, the subroutine that's going to be put into the background. Background, blink red LED. And I'm going to support a state here, background kill all, and when that is set, then I'll kill the thread. We're going to start off with a state instant being assigned to the clock second of the Raspberry Pi. And the while loop is going to be based on this background kill all. While it's not set, it will continue to loop. We're going to take the current instant, and I wanted to assign it one time from the system clock. So we have instant now set to the system clock second. Now we're going to do the test. If the amount of time has passed, as passed in from the main loop, which is this LED red toggle wait, when it exceeds that, then we're going to do we're going to toggle the LED. We're going to set it to not whatever it was. And when we do that, then we're going to update the state instant. So when the state changes, we're going to update the state instant. It's going to be the instant now. That's I didn't want to do a second clock. I wanted it to be the same value as the loop is running with. If indeed we exit out of the background kill, in other words, it is set, then we will not do the while. We will come out. I'm going to turn the red LED off and then explain to the user that the background loop finished cleanly. Here's where we have defined all the background information, the thread information. So we're going to have a threading event, which is going to be used to kill the thread. And we're going to call the thread, define the thread, I guess, using the routine that we created, the function that we created, and pass it the event that we're going to use to kill it. We have we go ahead and start the thread then with the call to start the background thread. And here's the expression logic that I used. Let's go down and look at what it does, and then we'll come back and look at the expression that was built. While true, we're going to ask for the user to input a value between 0, 1 and 1. And if it's not a number in that range, then it's going to explain to the user, hey, it's not in the right range, and ask them to enter another one. If they just hit return or type in exit or something like that, well, it won't be a number, and it will exit. We see here the Boolean response of the full match, regular expression full match. We're testing to see that it is a number that was entered. Now, keep in mind, this is ASCII at this point, so we're doing an expression comparison to see if the string contains numbers or ASCII numbers. If it does, or I'm sorry, and it's not blank, which probably isn't necessary. In any case, we'll set we'll use the float and create the duration as a float, so it's converted from ASCII to float. And then we're going to check to see that the number, we already know that the string had numerical digits in it. So now we're going to see if the number is in the range that we want to change the thread value. And if it is, then we simply say, hey, toggle weight is now the same as duration float. And of course, the thread will just start acting using this value. So it'll change the weight values. If it's not in the range that we've asked the user to enter it in, it's going to return, hey, you didn't give us a number in the range that we requested, and it'll bounce back and ask again and go through all this logic. However, if they do just hit return without typing anything, if the user hits return without typing anything in, or types something like I don't care, or exit, or get out of here, then it will drop down to this else. And the else is going to explain to the user, hey, you didn't put a number in here, so I'm going to exit just like I said I was going to exit. We're going to we're going to change the state of background kill all to be set. And we're going to wait for that to come back. And then we're going to say exiting the main loop finished, and then do the break and jump clear out. Okay, so let's see this thing run. Okay, should have cleared the shell screen down here. Okay, run. And I'm going to put in .1, okay? Oh, I didn't go back to the expressions. Let's go back and look at the expressions in a little bit here. 0.1, didn't change anything. 0.3. How's about .05? And okay, how's about 1.01? Is that in the range? That is not in the range. And if we type a real small number, not in the range. So it didn't exit, it just not taking it. So now if we hit enter without typing anything, then we're returning a null value and it should exit. And it certainly does. Just as we expected, notice that the LED is off. So everything worked as expected. Let's go back and look at the expression. I trust that that's going to be interesting. As I have spent much of my professional life working with the expressions, so I was quite eager to jump in here. Notice first of all that this is the expression. We're compiling this r/d asterisk slash period question mark /d asterisk, and that's the end of the expression. Now, in my reading of the notes, the R is somehow getting by what the compiler would typically try to translate this, and it might mistranslate what we want to happen. So the /d is an ASCII class of 0 to 9, and the asterisk here tells it you can have you can find a number, or you might not find a number. I don't care, and it can be as many numbers as you want. So in just consecutively. So that would be recognized as 100, or 100 would be recognized. 99 would be recognized. 1,000, any integer that you would think of that would be recognized. Now, we are also going to allow a dot to be found, a period to be found, and the question mark says, if you find a period, then that's fine. If you don't find one, it's okay too. So it's not necessary that you find a period, just like it's not necessary that you find a leading integer. After the period, we are going to look for another, another integer, 0 to 9. And the asterisk says you can find one, or you might not find one. It's okay. So integer dot integer, all of that will translate into a string that the expression recognizes as that we've defined as a number. Now, this expression that follows is identical to what we have above. It's just another way of writing the expression. Up here we used the D, which basically says a decimal digit, which is an ASCII 0 to 9. I said that already. Well, let's just put it. Let's define a group of characters. So a group of ASCII characters, 0 to 9. That's the same thing as the D, and we put that in the square braces. So, and again, we follow that with an asterisk. And the asterisk says, I don't care if you find anything or not, or you can find as many of these whatever you had in there in your match. So we told it to look for 0 to 9, and as long as you keep finding zeros and nines, then that's okay. And it's also okay if you don't find any zeros to nines, but you can't find anything. It better not be an ABC or something like that. The period that's repeated from up here, and once again we have a 0 to 9, just like we had in the prior expression. So that's how these expressions work, and I think that's all I had for you. I hope you're having a great day.